Okay, so today we are going to discuss about variables and frequency distribution, how to construct a frequency distribution and all those. So basically variables consist of, or they are of two types of variables, that is continuous and discrete variables. So as we see, variables differ on the basis of specific criterion. Depending upon the differences in criteria, they are divided or broadly classified into two, that is continuous and discrete variable. So what is a continuous variable? So a continuous variable can take any numerical value. So it may be integral values, it may be a fractional values, and it may be even not exact fractions, like as it is given here. Fractional values, it can take any fractional values or even integral values like 1, 2, 3. So example, height of a student is 90 centimeter to 150 centimeters. So in this example, the height of a student can be 100 centimeter or 90.5 centimeter, or even if it is not a whole number, it is a continuous variable, because continuous variable can take any numerical value, whether it is in whole number, integer, fraction, not even not exact, even not exact fraction, they are all under continuous variable. So unlike continuous variable, a discrete variable can take only certain values. So it changes their values only by finite jumps. So it is not changing or jumping its values indefinitely, but it is a finite jump, and it does not take any intermediate values. Mind you, it does not take any intermediate values, unlike like the continuous variable. So only whole numbers, it is taking the values of only whole numbers, so cannot take fractional values like 0.5 etc. Because when it comes to discrete variables, like there cannot be a concept of half a student. So it is an absurd term, because number of students cannot be half, it has to be a whole number. So it has to be either one student, two student, and not half student, 2.5 student. But we should also be careful that we should not have the impression that a discrete variable cannot take any fractional value. Suppose x is a variable, let's take an x variable. So it can take values like 1 by 8, 1 by 6, 1 by 32, 1 by 64. So these are fractions, okay? These are fractions, but these fractions are jumping in a finite number. So this is a discrete variable, though it is a fraction, it is in fractional form. So these are all fractional form, but then this is a discrete variable. But like fractions like 0.5 and all this, it cannot take, a discrete variable does not take this kind of fraction. But when it is jumping in a finite certain number values, it is a discrete variable. So by knowing the continuous variable and discrete variable, we move on to what is called a frequency distribution. Okay, frequency distribution. So with the help of this, table 3.3, I will be explaining, about the terms that we use in frequency distribution and how we got this frequency, what is the lower class limit, what is the upper class limit, and how do we find the class mark or the middle point. So what is a frequency distribution? Again, not a point that this datas or numbers are derived from the table, the previous table of the marks obtained by students in a mathematics examination. So we are using that data in this table to find out the frequency, class limit, and the class mark. So what is a frequency distribution? It is a comprehensive way. You are summarizing or making it concise. It is a comprehensive way to classify raw data, the raw table that we discussed. We are comprehending it and classifying the raw data in a quantitative variable. So it will show the different values of variable distributed in different classes along with their class frequency. So this is a frequency and this is the class. So here in the given table we have 10 classes, 1 2 3 4 5 6 7 8 9 10. So we have 10 class. So we are comprehending or classifying the datas in a frequency manner, in a lower class, in an upper class, or in a class marked tabular form. So when you mean by class, these are the classes 1 2 3 4 5 6. So this is the classes. And what do you mean by class interval? Class interval would mean you minus your lower class limit by upper class limit. So from 0 to 10, the class interval is 10. From 10 to 20, your class interval is 10. So in all these classes, your class interval is 10. The value of class interval is 10 here. So you minus your, upper limit value by the lower limit. There you got class interval. What is a frequency? Frequency would mean how many or how much of the values occur in this class. So when you look at the table, your row table, there are 1 values which is taking the value between 0 to 10, and in 10 to 20 you have 8 values. So how much? Here it is given. It shows the different values of a variable distributed in different classes along with their class frequencies. Class frequencies would mean how many times a number occurs within this range. So within 10 and 20, how many numbers are there? Within 10 and 20, how many numbers are there? So frequency, when you say frequency, it is given 8. So in between 10 to 20 number, values between 10 to 20 is 8. So 8 times a number happens between 10 to 20. So when you say, class frequency, it means the number of values in a particular classes. So looking at the raw data, you will see that between 10 to 20, you will find 8 values. Between 20 to 30, you will find 6 values. Between 30 to 40, you will find again 7 values which occurs. And again between 40 to 50 range, you will find, 21 values. And remember, each class in a frequency distribution table is bounded, bounded by class intervals. So they are bounded by class intervals. There is lower value and then lower class limit, or the highest value, or the upper class limit. So this is the lower value, this is the upper value. So class frequency is bounded by these two interval, by these two value. There is a lower value and the upper value. These are called the class limit. This is a lower class limit and this is the upper class limit. So it is bounded by this class limit, upper and lower class limit. So class interval or class wide is the difference between the upper class limit and the lower class limit. So when I talk about class interval, it is the difference between the upper class limit and then the lower class limit. So the difference between the upper class limit and lower class limit is the class interval, that is 10 here in this example. And what is a class midpoint? Class midpoint or a class mark. So it is the middle value of a classes. So it is the middle value of a classes. Middle value of a classes when you talk about class mark. So how do we find this class mark? We find this class mark or class midpoint by adding both these two. That is lower class limit, upper class limit, we add up and then divided by 2. And we got all this class mark. So when we add, 10 and 20, we get 30. And we divide 30 by 2, we get 15. And when we add 20 and 30, we get 50. And 50 will be again divided by 2, so we get 25. That is how we got the class mark. Let me repeat again in order to make sure that you are clear about frequency. Frequency is the number of times that values occur within this class interval. So within this 10 to 20, how many numbers occurs, or how many values occurs? How many times a value occurs? That is 8 times. So there might be 11, 12, 15, 17, 16, 19. So it will be 8 values that you will find within this class interval. That is the class frequency. How many times a value occur in this range is the class frequency. So, we can plot this, data in a graphical representation. That is called a, diagrammatical present frequency distribution of data. So with the given example data in table 3.3, there is the example we are plotting those data in a graphical form. So we got the data like this. So this is the presentation of frequency distribution of data in a graphical form. Again, while preparing a frequency distribution, you need to question, or you need to address 5 questions. That is, should we have equal or unequal, size class intervals? Number 2 question, how many classes should we have? Number 3, what should be the size of its class? Number 4, how should we determine the class limits? And lastly, how should we get the frequency for its class? So those are the questions that we have to answer while constructing a frequency distribution. So as I have told you, there are 5 questions that you need to answer while constructing a frequency distribution. So the first one is, should we have equal or unequal sized class intervals? So I have shown you how to find out class intervals, or what is a class interval. So class intervals, or class wide of the class, is the difference between the upper class limit and the lower class limit. So when we say class limit, let us say we have 10 to 20. So what is the class interval, or what is the wide of the class? It is the difference between this. So 10 is the class wide, or the class interval for 10 to 20. So that is an example of a class interval. So the question is, should we have equal or unequal size class intervals? That is the question. So there are 2 situations in which unequal size intervals are used. The first one is the case of unequal size intervals. First one is when we have data on income. Don't forget, when we have a data on income, we use unequal size intervals, not equally like this. So this is equal 10, 20, 20 to 30, 30 to 40. But unequal would mean, 10 to 20, 25 to 30, 35 to 40, 40 to 50, like this. So when I talk about unequal, I mean this is equal size class interval. When I talk about unequal, 25 minus 30, 35 minus 40, 40, 50. So this is an example of an unequal size data class interval, or unequal class interval. So here the class interval is 10, here it is 5, again here it is 5, again here it is 10. So this is an example unequal size class interval. When do we use this? We use this when it comes to data on income and other similar variables where the range is very high. Range would mean, the difference between the... So range is the difference between the largest and the smallest values of a variable. So when there is a very high range, we use this unequal size interval. For example, income per day may range from nearly 0 to 100 crores of rupees. So income of an individual is very high in range. Some may have zero income, some may have crores in income. So we use this unequal size data. So in such a situation, equal class intervals are not suitable. Why? Because if the classes intervals are of moderate size, are of equal, there would be a large number of classes. So when there is a high range, let us say income ranging from 0 to crores of rupees, then your size and your intervals will be of very huge, and it is not possible to construct. Secondly, if class intervals are very, very large again, then we would tend to suppress information on either small levels or very high levels of income. So information would be lost if your intervals are large. And if your intervals are small again, then it would be very lengthy to construct a frequency distribution. Secondly, if a large number of values are concentrated in a small part, large numbers of values, again, if they are concentrated in one particular, range, then equal class intervals will lead to lack of information on many values. And then loss of information and the lack of information is bound to happen when we have, a large number of values concentrated in a single, or when they are concentrated in small part of the range. So in all these other cases, equal size classes intervals are used in frequency distribution. So the next question that we have to answer is, how many classes should we have? I have told you what is the class. Here 10, let us begin with 0, 10, 10, 20, 20, 30. So these are all classes. So how many classes should we have? So we have 3 classes only here. So we have to also see to how many classes should we have. So normally or usually the classes is usually between 6 or 15. Minimum usually is 6 and maximum can be 5. It is usually like that. So in case we are using equal sized class intervals, then number of classes can be calculated by dividing the range by the size of the class intervals. So when we are using a equal size class intervals, we can find the number of classes can be calculated. How do you calculate number of classes? By dividing the range by the size of the class intervals. So I have told you range would mean the difference between the smallest and the largest values of variable. So we are taking the example once again of the table 3.1 in your previous table. Refer to previous table 3.1. So we are taking that example. So when we are using in case of an equal size class interval, we can calculate the number of classes. How? By dividing the range by the size of the class interval. So range is the difference between the highest and the lowest value of variable. So in the previous table 3.1, your range is 0 to 100. So when we calculate range, we get 100. And your class interval was 10. Class interval is the difference between upper limit and the lower limit. So we get 10 as the class interval. And to find out the number of classes, we have to divide this range by the class interval. So when we divide this, we get 10. So we find out that when we are using an equal size class interval, we can find out the number of class. That is 10 in case of here, table 3.1. Okay, the third question is, what should be the size of its classes? Size or the class interval? So how should we decide this? So, the previous questions and these questions are interlinked, and it cannot be, decisions should not be taken separately. Decision is interlinked when it comes to question number 3 and question number 2. How many classes should we have, and then what should be the size of each class? So given the range, let us say 0 to 100. 100 is the range. So given this range of the variable, we can determine the number of classes once we decide the class intervals. So given this range, that is 0 to 100, we can decide, or we can determine the number of classes. As I have shown you in the, calculation, the previous question. So we can determine the number of classes. And this number of classes, again, will determine the size of the classes automatically. Once given the range, you can determine the number of classes. And this number of classes, again, is interlinked with the size of the classes. So they are interlinked, and decisions should not be taken separately. It is interlinked. For example, we have the number of classes as 10 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the class intervals are automatically 10. So class intervals is automatically 10. So we have seen how to find out the number of classes given the range and also the class interval. Class interval is the difference between upper class limit and lower class limit. So, given the value of range as 100, the class intervals are automatically 10. It is 10. So, dividing the class intervals and the range, we got 10. So, note that in the present context, we have chosen classes intervals that are of equal magnitude. They are of equal in size. So, they are equal in size, class interval. So, however, we could have chosen classes intervals that are not of equal magnitude. So in this case, the classes would have been of unequal weight. So we have taken this case as an equal size class interval. But if it is not an equal size class interval, then, we would have, or the classes would have been of unequal weight. We would have a difference, or we will not have the same class interval or the class weight. So the next question is, how should we determine the class limit? So class limit consists of the lower class limit and the upper class limit. So basically there are two types of class intervals. One is inclusive class intervals and exclusive class intervals. So class limit, should be very definite and clearly stated. Generally like open-ended classes such as 70 and over or less than 10, they are not desirable. It should be stated definitely and clearly. So the lower and the upper class limit, should be determined in such a manner that frequencies of its classes, tend to concentrate in the middle of the class intervals. So it should not go out beyond this class limit. So it should be properly stated or clearly determined so that frequency can be, identified easily. So class intervals are of two types, as I have mentioned. One is inclusive class intervals. So in case of inclusive class intervals, as you can see in the example, in this case, values equal to, the values which are equal to the lower and the upper limits of classes, are included in the frequency of that classes. So values which are equal to 0 and within 10, with values which are equal to 0 from within 10, they are included in the frequencies here in case of inclusive class intervals. So what about, exclusive class intervals? So in this case, an item equal to, either the upper or the lower class limit is excluded. So in this exclusive class intervals, an item or a number which is equal to either the upper limit or the lower limit is excluded in the frequency of that class. So here it is excluding, or they are not included. Here it is included. The value of lower and the upper limit is included. Here the value of lower and upper limit is not included here. And both this inclusive and exclusive has a definite purpose and uses. So in the case of discrete variables, which means discrete, both exclusive and inclusive classes intervals can be used. In case of this discrete, we can use both this class intervals, this type of class intervals. But in the case of continuous variables, inclusive class intervals are used very often. In case of these continuous variables, inclusive class intervals are very used oftenly and not exclusive.